Assalamualaikum and hi to Madam Siti Saleha. This is our assessment 2 video presentation, Calculus 1, MAT183, and we are from F4AS 120 to 17 R star. So, our title of presentation about technique of differentiation. This is our group members. So let me introduce myself first. My name is Nur Afrika binti Muhammad Azlan and my team is Muhammad Darwish, Nurin Marhanis and Nur Intan Alia. Question 1. So this question asks us to explain the meaning of differentiation and the technique used to perform it. So first, what is differentiation? Differentiation is a process in calculus used to find the rate of change of a function. In simple words, it tells us how a value changes with respect to another. For example, how distance change with time or how fast something is moving, which we call velocity. Differentiation helps us understand the slope or steepness of a curve at any point, and it used in many real life situations like calculating speed, acceleration, or even to find maximum profit or minimum cost. Now, let's look at the main technique of differentiation. First, we have the power rule. If the function is x the power of n, the derivative is xn the power of n minus 1. Next is the constant rule, where the derivative of a constant number is always 0. We also use the higher derivative, sum and difference rule, product rule, equation rule, and the chain rule depend on the form of the function. Each of these techniques help us solve more complex functions step by step. That's all from me. Next, question number 2, I will pass to Nurin.
Now we move on to question 2. For 2a, we need to find dy dx for 3x squared secant x plus 2. To find dy dx for the function y equals to 3x squared secant x plus 2, we use the product rule because the function is a product of two different expressions. We identify the first part as u equals to 3x squared and the second part as v equals to secant x plus 2. Next, we differentiate each part separately. For u equals to 3x squared, the derivative is u prime equals to 6x. For v equals to secant x plus 2, we apply the chain rule since it's a composite function. The derivative of v is v prime equals to secant x plus 2 tan x plus 2. After finding the derivative, we substitute everything into the product rule formula, which is dy dx equals to u prime v plus uv prime. Substituting in the values, we get dy dx equals to 6x times secant x plus 2 plus 3x squared times secant x plus 2 times x plus 2. Now we move on to question 2b. To find dy dx for the function y equals to 4x plus 2 over cos x, we use the quotient rule since the function is a division of two separate functions. We define the numerator as u equals to 4x plus 2 and the denominator as v equals to cos x. Next, we differentiate both parts to obtain u prime equals to 4 and v prime equals to negative sin x. Using the quotient rule formula, which is u prime v plus uv prime over v square, we substitute the value into the equation. dy dx equals to 4 times cos x minus 4x plus 2 negative sin x over negative sin x. Because of the two negative signs in the second term of the numerator, it simplified to a positive expression. Therefore, the final answer for the derivative is dy dx equals to 4 times cos x minus 4x plus 2 negative sin x over cos square x.
For the question 3, the question is given y belongs to x minus exponent 2x plus 1 minus tangent 4y equals to 0. Find dy over dx using implicit differentiation. Step 1. Differentiate both sides with respect to x. We have three functions on this equation, which is y belongs to x, exponent 2x plus 1 tangent 4y. The second, we need to put all the derivative together after we differentiate all these function. Third, we need to solve for the dy over dx. Now let's go to the first step. First, we differentiate the y times 3x. We need to using the product rule. First, we differentiate for each of the function and we rearrange into the equation of the product rule. Next, exponent to x plus 1. By using chain rule, we differentiate the exponent to and get the value to exponent to x plus 1. The third one, tangent for y. First, we need to solve the tangent function where we get tangent equal to secant squared, and after that, we differentiate in a function by using chain rule and we rearrange the value into the equation. After all, we put all the derivative together. Assemble the differential equation to the original equation. Means all the differentiate function we assemble back to the original equation. Lastly, we solve for dy over dx. First, we need to move the non-dy over dx term to the right. After that, we factor out the dy over dx. And finally, we divide the both sides.
Next is for question number 4. Use linear approximation to estimate the value of the fourth root of 80.99 minus 2 over square root of 80.99 correct to 3 decimal places. Firstly, let fx equal to the fourth root of x minus 2 over square root of x. Fx equal to x power of 1 over 4 minus 2 over x power of 1 over 2. Fx equal to x 1 over 4 minus 2x power of negative 1 over 2, and then find the second derivative, which is f prime x equal to 1 over 4x power of 3 over 4 plus x power of negative 3 over 2. So the answer we will get is 1 over 4x power of 3 over 4 plus 1 over x power of 3 over 2. So the next step is we will use the formula dx equal to x over x naught. For x equal to 80.99, for x naught equal to 81. So by using the previous formula, which is x minus x naught, we will get 80.99 minus 81, and the final answer is negative 0.01. Next, we will use the formula f x naught plus dx equal to f x naught plus f prime x naught dx. So by using the value given, the first root of 80.99 minus 2 over square root of 80.99 equal to f 81 plus f prime, which is 81 times negative 0.01. And then after that, we will get the first root of 81 minus 2 over square root of 81 plus 1 over 4 times 81 power of 3 over 4 plus 1 over 81 power of 3 over 2 times negative 0.01. And then after we simplify, we will get 3 minus 2 over 9 plus 1 over 108 plus 1 over 728 times negative 0.01. And then we will get 2.7777. For the final answer for 3 decimal places, we will get 2.778.